Hi, in this quick little tutorial I'm going to show you how to model and program this little widget for the CNC plasma cutter. Start by saving your work. I'm not going to save this because I don't need to. It's a quick little demo. You're going to go new sketch, starting on this bottom plane, making sure our Z-axis is pointing up. We're going to start with a rectangle. It doesn't have to be at the origin, but it might as well be. It's going to be 3 inches tall, tab over, 4 inches wide. Enter. It's going to have a circle in the center. I'm not going to draw it centered right now because I'm going to go back and dimension this circle to be 2 inches, and then it's going to be center to edge at 2, because we got 4 divided by 2 is halfway, 2 inches, and then this should be 1.5. Going to have a circle right about here. That's going to be a 0.5 half-inch diameter, and that circle is going to be from the center to the top edge 0.5, and the center to the left edge 0.5. This is going a little too fast. I'd highly recommend you slow it down in your YouTube browser. And the next step, we need to recreate the 3 holes. You can just basically do those previous steps over, or we can use a mirror tool to mirror our circles. So I'm going to go line tool, X, turn it to a construction line. I'm going to draw a vertical axis. Once again, L for line tool. I'm going to press X. Construction line is on. This construction line won't interfere with any other geometry, just kind of for reference. Sketch, mirror, click on our circle, click on our mirror line. So there's that, and then right click, repeat mirror, click on that one, click on that one, select the other mirror line, click OK. And what's nice, if we need to make changes, it will automatically update all of the other holes. Next step in the 2D workspace is going to be a fillet for the 4 corners, and that's going to be a radius of 0.5. Half-inch radius. Enter. E to extrude. I'm going to bring this out to a 3D view. I'm going to pull it to get it started, and that thickness is 0.06, approximately a 16th gauge, approximately a 16th of an inch. Enter. That is it for the 3D model for our widget. We're going to hop over into the CAM workspace and set up our part. First thing we need to do is do a new setup. Change the operation type to cutting. Our work coordinate system defaults to the middle, but we want to pick this top, bottom, left corner, or X to the right, Z up, and Y going away in this direction. Stock tab. We want to add 0.1 to the side and 0 to the top. That gives us enough border around our part for our stock so we don't cut into something else and not waste material. And that gives us our overall XYZ stock size for our dimensional stock right here, 4.2 by 3.2. Post-process, you can type in a program name or number. I'll just call this 4 by 3 with my initials, and then the comment's going to be V1 because it's version 1. Click OK. We now have our setup. Next thing we need to do, you might have already done this before, but we're going to go ahead and do it a little different ways. Set up a cutting tool for the plasma cutter. Up here on our tool library, we're going to click on that. And then over here in the top right hand corner, we have a new cutting tool for a water jet laser or plasma. Going to go to general. We're going to call this the 40 amp plasma. Don't worry about the vendor, product ID, and links. That's a little overkill for what we're doing. Cutter is going to be a plasma cutter. Changes kind of the tool holder. Ours doesn't exactly look like this, but it really doesn't matter. Our kerf width is going to be 0.037. And let's give it a nozzle clearance diameter of 0.05. This is all in inches. Holder, this doesn't matter. Feeds and speeds. Our machine is going to use feeds and speeds. Our default cutting feed rates, let's go ahead and just change this to actually like 0. This will force us to change it later. You will change, I don't even know if it lets me do 0. We'll see. Let's go 1. Because we will need to change our feeds and speeds depending on the thickness of material that we're cutting. If we're cutting thick metal, we're going to go slower. If we can cut thin metal, we can go a little bit faster. And those are all set up with templates out in the shop as far as what your feed rates are for certain thicknesses of material. By putting it at 1, it definitely lets you know that you need to make a change. Going to click on our post processor. This is going to be tool number 1, and comment is going to be 0.03740 amps. If you jump up to a 60 amp cutting nozzle and you're cutting thicker metal, the width of your kerf is going to increase. And this is close enough. Going to click OK. So we now have our 0.037 plasma cutter saved in our tool library. You can save this locally or within the cloud. I'm going to close that. Cutting operation up here on the top, 2D profile. Select our tool. Going to find that tool right here that I just created. You can take this tool, duplicate it, copy it into your cloud library, or you can just copy it from a previous part. There's a lot of different ways to do it. So there's our 40 amp plasma. You're going to click OK. This is where we're going to change our feed rate. So cutting feed rate 150. Our lead in's typically going to be a little bit slower, so we'll go 130, and lead out can be 150. These can all be 150, but we'll just kind of learn the concept that our lead ins, where it's piercing, we maybe go a little bit slower when we're making that little lead in pierce cut. Cutting mode is going to be auto. Geometry is going to be this top surface. That gives us our direction that the tool is going to be on. So our tool is going to be on the outside of our selected geometry for the outside, and then inside or here. And tabs. Don't really need tabs for this part since it's big enough. It's not going to fall through the slats, but for the sake of learning, we're going to add tabs by points. Typically, I like to add my points or my tabs manually with points. Tab position, we're going to put 1 tab here and 1 tab here, and this will allow us to break this part off. You don't need multiple tabs. If you put tabs all the way around this, you're not going to be able to snap it off from the sheet. Our tab width for cutting this thickness of metal at this amp and feed rate is going to be 0.13 inches for our tab width. Heights, there's nothing to worry about here. These default values are fine. Passes, we're going to change our compensation type to in computer, so it creates a G code based off of the diameter of our tool, which is 0.037. And that's fine for this tab. And our linking, we're going to change our lead-in sweep angle to 90 degrees. And our lead-in distance can actually be a little bit shorter. We're going to go 0.1 for our lead-in distance. If your lead-in distance is really long, sometimes you have a difficult time, Fusion has a difficult time making a tool path inside a small hole. This hole is big enough so it wouldn't be a problem, but typically if you're not getting a tool path in a small feature in your part, it's because your lead-in lengths are too long. So 0.1 is typically about as small as we need to go, and then our piercing clearance is going to be the nozzle diameter. This could also be maybe that 0.05. And that's it for our cutting operations. We see here we have where it starts in. It's going to cut out this hole, then it's going to link over, and it's like then cut out this one, and then this one, and this one. And why am I telling you this? Because we can just watch the simulation. Notice I have my tools changed to flute. If you go to holder, this kind of blocks it. It's really not necessary for our simulation. There's definitely not going to be any collisions. This kind of gives you a little more accurate view of what's going on. We can see our lead ins, we can see our tab and our lead out, and you can also toggle off between your model on and model off. You can't really see anything because it's exactly the same size. You can turn off your stock, and then you can watch your simulation again. Can't really see much with the stock off. Typically I like to have my model off and my stock on for the simulation. So that looks good. Hopefully you're saving frequently. And the final step is going to be post-processing. We're going to take this visual information and Fusion's going to turn it into G-code for our CNC plasma cutter via a post-processor. So find the G1, G2 button. Make sure you have your setup 1 selected. It's going to have your tool path underneath. We're going to turn our model back on. Post-process. Go to setup, make sure you're using your cloud post because that's where your Techno CNC plasma cutter post processor is stored. Make sure you got the /Techno plasma post processor, final chance for a program name or number and a version number, and hit post. And this is where you will save it on your flash drive and take it out to the CNC plasma cutter. Thank you. Good luck.